Okay, number 1 says a function is defined by the equation shown here. Which equation defines the inverse of the function? All right, well, we know whenever we want to find the inverse, we want to switch the x and the y. So I'm going to change this to x equals 1/2 y minus 3/2. And at this point, we just have to get the y all by itself. So I'm going to first add 3/2 to both sides of the equation. So that leaves me with x plus 3/2 equals 1/2 y. Now, to get rid of the 1/2, you could do one of two things. You could divide both sides of the equation by 1/2, but then you're going to be dealing on this side with fractions within fractions. So I think an easier way here is just to multiply both sides by the reciprocal of this 1/2. The reciprocal of 1/2 is, just flip it upside down, 2 over 1. So if I multiply both sides of the equation by 2 over 1, or which is the same as just 2, what's going to happen is on the left-hand side, this 2 on top cancels off with the 2 on bottom. I mean, I guess you could do the same thing with the 1s if you want, leaving me with just y. And here, when I distribute 2 over 1 times x is 2x, and then plus, well, 2 over 1 times 3/2. This 2 on top is going to cancel off with this 2 on the bottom, so it's just going to leave us with 3 over 1, which is just 3. So our inverse is just equal to 2x plus 3. Okay, in number 2, they give us a picture of f of x, and on the same set of axes, they want us to graph y equals f of x minus 3 plus 2. Okay, so this in here tells us that we're going to be shifting 3 units to the right, and this tells us we're going to be shifting 2 units up. So what you're going to do is you're just going to take each of these points on the graph and just shift them. So you could see here this point 0, 0. If I were to take it and go 3 units to the right and 2 units up, it would leave me right here. Okay, so you're going to do it for every point that, is really kind of an obvious point to see. So this next point right here, 1, 1, I'm going to do the same thing. I'm going to go over 3 and up 2. Okay, the next one I guess I could see has the coordinates 2, 4. So if I go over 3 and up 2, it's going to land me right here. Now, the final point that I could see on the right-hand side of the parabola here, actually I can't really tell these, but even if I were to graph any of these, I think it would go off of the graph. So I'm going to leave that side alone. Now I'm going to shift this point as well. Negative 1, 1, so I'll go over 3 and up 2. And if I shift the point negative 2, 4, I'm going to again go over 3 and up 2. All right, so these are the only points I really can shift that I'm going to fit on the graphs that I could fit on this set of axes. So that right there is the graph of y equals, make sure you label, f of x minus 3 plus 2. Okay, so number 3 talks about the hold time experience by people calling a government agency. And they tell us the mean hold time is 12.4 minutes and the standard deviation is 4.3 minutes. So in part A, they want us to determine the number of calls answered in less than 5 minutes. Or they want us to find the percentage of calls that are answered in less than 5 minutes. Okay, so I'm just going to think about how this looks with a normal distribution curve. If we were to draw out a normal distribution curve, we know that the mean is 12.4. So 5 would be somewhere to the left of the mean. So if we want to figure out the percentage of calls that are answered in less than 5 minutes, we're looking for the probability that the time lies to the left of 5 on our chart. Okay, so first we have to figure out the z-score that goes along with 5. So it would just be z equals the value minus the mean, so 5 minus 12.4, divided by the standard deviation, so divided by 4.3. When you do that, you get negative 1.7209. So that just means that 5 is 1.7209 standard deviations below the mean. So if we want to figure out the probability that the wait time is going to be to the left of 5, that it's going to be in this area, we really just need to use, we can use our calculator to do normal, CDF, and we need to put in a lower bound and an upper bound. So our lower bound is going to be, I mean, really what we want to do is we want to pick a really, really small number over here. I usually use negative 9999. And then our upper bound would be this right here. So we're going to have negative 9999, and our upper bound is negative 1.7209. Okay, when you plug this in the calculator, it does give you as a decimal 0.043, but because they want the answer to the nearest tenth of a percent, you'd have to move the decimal place over twice, which gives you 4.3%. Okay, part B wants to figure out the probability that the call lasts between 10 and 15 minutes. So if, again, our average is 12.4, 10 would lie to the left of it, and 15 would lie to the right of it on our normal distribution curve. So this time we have to figure out the z-score that goes along with each of these. So to find out the z-score that goes along with 10, you're just going to take 10 and subtract the standard deviation from it, and, subtract the mean from it, and divide that by the standard deviation. So when you do that, you get negative 0.5581. Okay, now if we want to find the z-score associated with 15, we do 15 minus the mean and divide that by the standard deviation, and that gives us positive 6047. So that means that 10 is 0.5581 standard deviations below the mean, and 15 is 0.6047 standard deviations above the mean. So if we want to find out the percentage of scores that fall in this area, this time when we do the normal CDF in our calculator, our lower bound is the negative 0.5581, and our upper bound is the 0.6047, and your calculator as a decimal gives you 0.451, but again, they want it to the nearest tenth of a percent. So when you move the decimal place over twice, you get 45.1%. Number 4 says an urn contains 10 red balls, 4 green balls, and 8 yellow balls. 4 balls are chosen at random without replacement. Determine the probability of choosing 3 red balls and 1 green ball. Okay, well, as soon as we see probability, I'm going to draw a fraction bar. And in the numerator, we're going to write the number of ways we could choose 3 red and 1 green. So from the 10 red, we would want to choose 3, so we could write that as 10C3. And we're using C because order does not matter. The word and tells us we have to multiply. And from the 4 greens, we want to choose one of them, so 4C1. Now the denominator contains the total number of balls we have and the total number that we want to choose. All right, so if you add these up, we have 22 in total. So from the 22, we want to choose a total of 4. So, I mean, you could just plug this in your calculator. It winds up 10C3 is 120, 4C1 is 4, and 22C4 is 7,315. So when you multiply that out, that becomes 480 over 7,315. Or if you want to simplify it, that simplifies to 96 over 1,463. Okay, well, what's nice about number 5 is not only do they give you the formula, but they tell you what everything in the formula stands for. So it says, after sitting out of the refrigerator for a while, a turkey at room temperature, which is 68 degrees Fahrenheit, is placed into an oven at 8 a.m., where the oven temperature is 325 degrees. Tells us what Newton's law of heating is, gives us the formula. Then it says in part A, okay, it says the turkey reaches a temperature of approximately 100 degrees Fahrenheit after 2 hours. Find the value of K to the nearest thousandth, and write an equation to determine the temperature of the turkey after T hours. Okay, well, so since T of T is really just representing the temperature after a certain time, they're telling us after 2 hours the temperature was 100. So I'm going to replace the T of T with 100. Now, T sub A is just the temperature of the surrounding object. So it's the oven temperature in this case, which is 325. And then plus T sub 0 is the initial temperature. So the initial temperature of the turkey was 68 degrees. I'm going to subtract from that the T sub A again, which is 325. And that'll be e to the, we're going to leave this as negative k because that's what we're solving for. And I could replace the little t with a 2 because they told us 2 hours have passed. Okay, so then when I solve this, I'm just going to do 100 equals 325. And then 68 minus 325 is negative 257. So I'm going to bring that down as well as the e to the negative 2k power. All right, so our goal right now is just to get this e to the power by itself. So we're going to first get rid of this 325. So we could subtract 325 from both sides of the equation, leaving us with negative 225 equals negative 257 e to the negative 2k power. And then to get rid of that number in front of the e, we're just going to divide. Now, I'm going to just leave this as a fraction. I mean, a negative divided by a negative is a positive, so I'll leave it as positive 225 over 257. And that's going to be equal to e to the negative 2k power. All right, now in order to get rid of an e, we have to put ln in front of both sides of the equation. So the ln and the e cancel each other off, so we're left with the left-hand side of the equation being equal to negative 2k. And to finish this off, just divide both sides by negative 2. And they ask you to round to the nearest thousandth. So we get k equals 0.066. Okay, this part also asks us to write an equation to determine the temperature of the turkey after T hours. All right, so it's going to be pretty similar to what we have up here. The only difference is we're going to leave this as T of T, and we'll leave this as a little t. And now we can plug in our k. So we'll have T of T equals 325 plus 68 minus 325 times e to the negative, now we can plug our k in, so 0.066 times t power. So that's one way you could write it. Another way you could write it is if you want to combine these two to give you negative 257, you could rewrite this as T of T equals 325 minus 257 e to the negative 0.066 t power. Either one of these is fine. Okay, now part B says determine the Fahrenheit temperature of the turkey to the nearest degree at 3 p.m. Okay, so, I mean, at 3 p.m., if they put the turkey in the oven at 8 a.m., then 3 p.m. would be 7 hours later. So what we're going to do is we're going to use, I'm going to use the second equation right here, and all I'm going to do is replace the little t with a 7 because it's 7 hours later. So we're going to have T of 7 equals 325 minus 257 e to the negative 0.066 times 7 power. And, I mean, you could just plug that right into your calculator, and when you do, I wound up with 163.0843, but they wanted it to the nearest degree, so it would be 163 degrees Fahrenheit.